Hello, I welcome you to Data Structure and Algorithm Masterclass. And in this series, we will be looking at the available module on data structure and algorithm. We'll be looking at data structure, type of data structure, big O notation, big O notation code example for time complexity, big O notation code example for space complexity, implementation of different type of data structure, algorithm, type of algorithm, implementation of different type of algorithm. So first of all, what is data structure? A data structure is a way of organizing and storing data in a computer program on a system so that it can be accessed and used efficiently. Data structures provide a means to manage and manipulate data, making it easier to perform various operations such as searching, sorting, inserting, and deleting. Mastering data structure is like knowing the best tool for the job. Think about a technician who has a toolbox and wants to solve a problem. He has to pick the right tool to solve the job, else he won't be able to solve that job. Not knowing the right tool to use will keep you struggling and frustrated. Look at the picture on the left. A technician wants to drive a screw that requires a star screwdriver. Now he is attempting to use a flat screwdriver. Look at the picture on the right. A technician wants to drive a screw that requires a flat screwdriver. Now he is attempting to use a star screwdriver. You can already guess what is going to happen. Definitely, he is going to struggle and be in a very bad state. So the takeaway here is not knowing the right tool to use will keep you struggling and frustrated. Let us explore the properties of data structure. We have two types of data structure. We have the primitive data structure and the non-primitive data structure. In the primitive data structure, it has the properties integer, float, character, boolean, and strings. While in the non-primitive data structure, we also have a two subtype, which is the linear data structure and the non-linear data structure. And this is basically where things are going to get more interesting. So the linear data structure has two properties, which is the linear static data structure and the dynamic data structure. Under the static data structure, we have the array, and under the dynamic data structure, we have the linked list, stack, and queue. If we go back to the non-linear data structure, we have tree and graph. What is a primitive data structure? A primitive data structure is considered as the fundamental data structure and it allows storing the value of only one type. I want you to underline this part. Only one data type. And in the primitive data structure, we already talk about the properties it have, which is the integer, float, character, boolean, and string. A non-primitive data structure is a data structure that can store more than one type. Non-primitive data structure has two types, which is the linear data structure and the non-linear data structure. I want you to understand the difference. The difference between the primitive data structure and the non-primitive data structure. The primitive data structure can store only one type. For example, an integer can only accept a numbers, which is an integer. We can put a string in an integer. Same as a string, we can put numbers in a string. While the non-primitive data structure, it accepts more than one data type. I want you to take that down, write it somewhere because it is very important. Now, what is a linear data structure? A linear data structure is one where data items are arranged in a linear fashion. Each member is attached to each neighboring element. The structure permits single-level data storage because the data elements are stored in a linear fashion. The data can be traversed in one run. The properties of the linear data structure is array, linked list, stack, and queue. For now, we're going to talk about array. An array is like a container, right, with a position. It has an index. The index is, it normally starts from 0 to the length of the array. And every index has a value. And you can see at index 0, we have the value 17. At index 1, we have the value 19. And that fashion goes on. There are a lot of things we're going to cover, and before we start doing the implementation, it is important we know and understand what is big O notation. So in the next video, we are going to explore and demystify big O notation. Please ensure you subscribe and turn on the notification bell so that when we post a new video, you will receive a notification. Thank you very much for watching. I'll see you in another video.